Namaskar, welcome to CTET Mathematics Preparation classes of session 2. So in this session, we will be discussing about the geometry of another concepts. So those concepts are Pythagoras theorem and the congruence of triangles. So these are the concepts we will be discussing in this session. Then, so if you analyze the previous year questions of CTET paper 1, paper 2, from it, especially from these particular concepts, they have been asking 2 to 3 questions from the paper 1 and paper 2. Okay, so where majorly focusing on Pythagoras theorem, and so based on the Pythagoras and triplets and triangle congruency and the concept of the congruency. So these are the concepts where majorly they are focusing in the paper 1, paper 2. From the previous questions. Now let us try to understand what is the concept of Pythagoras theorem, what is the concept of congruency, and what are the types of congruency triangles are there, and how these concepts can be applied when we are solving the mathematics problems. Okay, so moving to the next. Okay, so now let us try to understand the basic concept of Pythagoras theorem. Okay, so what is it Pythagoras theorem? So what is the meaning of definition of the Pythagoras theorem? Basically it says so in any right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides, such as base B and perpendicular P. Okay, so then we say that condition, this is the Pythagoras theorem. Okay, so that means let us try to understand much more deeply here. Okay, so in a right angle triangle, okay, so right angle triangle means the one angle will be exactly the 90 degrees. So here what is the exact angle 90 degrees here? Angle B is the 90 degrees. Okay, so then we say that this triangle is a 90 right angle triangle. So in any right angle triangle like this, okay, the square of the hypotenuse, that means this square of the hypotenuse, which is equal to the sum of the squares of the base and sum of the squares of the base and the perpendicular or adjacent, or we also say that adjacent side. Okay, so that means AC square is equal to, what is the AC here? Hypotenuse of the right angle triangle, AC square. So that is equal to sum of the squares of the other two sides. So that means BC square plus another side is the AB square. Okay, so this is the definition for the Pythagoras theorem. Okay, so what is the AC here? That is the H, that means H square, hypotenuse square. BC means base, B square, and P means a perpendicular, that is another adjacent side, P square. Okay, so when values are satisfied in this condition, then we say that the given triangle, right angle triangle, it is in the Pythagoras theorem. Okay, so where angle B is the right triangle, right angle, and AB is the perpendicular, BC is the base, and AC is the hypotenuse. So in a right angle triangle, whenever you see the Pythagoras theorem, hypotenuse is the longest side. Okay, so where other two sides are will be the smaller sides of the hypotenuse. Okay, so according to the Pythagoras theorem, the formula can be written as H square equal to P square plus B square. Okay, so now so whenever we try to understand the Pythagoras theorem, we also try to see the Pythagoras and triplets. Okay, so that means the Pythagoras and triplets are nothing but these are the values are the sum of the set of the three positive integers such as like A and B and C, where these three values satisfy the theorem where C is the largest side. Okay, for example, let us take, if we take here the triplet 1, 3, 4, 5. Okay, so in out of the let us A is equal to 3, B is equal to 4, and C is equal to 5. Okay, so in the given positive integers, what is the highest positive integer here? The 5 is the highest positive integer. So therefore we are saying that this is the hypotenuse. Okay, so where others 3 are the smaller than the 5, then we are saying that 3 and 4 are the other sides of the smaller side of the hypotenuse. Okay, so that means when these three positive integers satisfy in the given condition, Pythagoras condition, then we say that these are the triplets of the that means these positive integers are the Pythagorean triplets. Okay, so that means when you square this, like, so suppose let us try to apply 3 4 5 into the Pythagoras theorem. Okay, so now what is the hypotenuse here? 5 square. Okay, so what is the p square perpendicular? 3 square. Okay, so what is the base here? 4 square. Okay, 4 square. Now 5 square means what is the value of 5 square? It is a 25. So what is the value of 3 square again? 9. Okay, what is the value of the 4 square? That means 4 into 4, it becomes a 16. So 25 equal to 9 plus 16 will become a 25. So when this can satisfied, the values are positive integers satisfying the Pythagoras for condition, then with these 3 4 5 values are, we say that these are the Pythagorean triplets. For any competitive exam, if we, even for the CTET, we need to remember the Pythagoras triplets minimum 1 to 5 3 Pythagorean triplets we need to remember. So if you remember these things, without much calculation, by seeing the numbers itself, we can within the fraction of seconds, the whatever the question, when they ask the questions based on this Pythagorean triplet, by seeing the numbers itself we can answer. So here, when you know that these 3 4 5 are the Pythagorean triplet, you just remember the multiples of the 3 4 5. So that means, like, if you remember just 1 minute. Okay, so now if you remember multiples of the 3, so that means 3 2s are 3 3s are 3 4s are 3 5s are 3 6 are 3 7 3 8 3 9. Okay, 3 10, like that. So if you like keep on, if you remember the multiples of the 3. Okay, so all the multiples of 3 again, 3 4 5, the combination of 3 4 5 again, same like multiples of 4 2 4 3 4 5, so again multiples of 5 2 5 1 2 3 4 5 6 7 until infinity. If you remember the multiples of 3 4 5, so this all the multiples of 3 4 5 again will satisfy the condition of the Pythagoras theorem. Okay, so just we have to whenever the question asked from the Pythagoras theorem, remember this triplets, then easily we can answer. Similarly, if we take the 5 12 13, the positive integers such as ABC, so these also will be satisfy the condition of the Pythagoras theorem. Okay, so where 5 is the perpendicular adjacent side, base is the value of the 12, and the hypotenuse is the 13, which is the longest side. Okay, so multiples of 5, if you remember, okay, multiples of 5 if you remember, so all the multiples of 5 again it will satisfy the condition of the Pythagoras theorem. Similarly, if we take 7 24 25, okay, so these 7 24 25 also will satisfy in the condition of the Pythagoras theorem. Okay, so where longest side side is the 25, that is the hypotenuse, where others are this is the base and this is the perpendicular. Okay, so again if you remember the multiples of 7, so multiples of all the 7 they satisfy in the given Pythagoras theorem in the condition. Okay, similarly 8 15 17, if you see that, okay, so hypotenuse is the 17, 8 and 5 are the other sides. Okay, so now again, so 8 15 17 also will satisfy in the Pythagoras theorem. Okay, so again if you look at the multiples of the 8, okay, 8 1s are 8 2s are 8 3s are 8 24, again 15 1s are 15 2s are, like 17 1s are 17 2s are. If you remember all the multiple remember if you do the multiples of 8 with the 8, okay, so those values also again satisfy the Pythagoras theorem. Okay, again similarly 9 40 41, okay, so there's like many infinitive Pythagoras triplets are there. Okay, so if you remember these values, basically all the questions will be asking based on whenever they ask the question related to Pythagoras triplet, so basically they'll ask from the 3 4 5 or 5 12 12 13, or either 7 24 25, or either 18 15 17, or either 19 40 41. Okay, if you remember these things, these kind questions based on the Pythagoras theorem and Pythagoras triplet, easily we can solve. Now, if so for a quick remember tip, okay, if you two sides of the right hand triangle match any triplet, the third side must be remaining number in the triplet only. So now, so another concept which we need to remember discuss before we solve the CTET previous questions, that is congruence of the triangles. So congruence criteria we have to see. Okay, so what is the meaning of that congruent means? If the two triangles are congruent, if they are identical in both the in terms of the shape and in terms of the size, then both the triangles we say that these are both the triangles are the congruent triangles. So that means in a congruent triangles what will happen, the corresponding angles and corresponding sides also must be exactly, the angles and sides exactly perfectly should match. Then we say that both this triangle 1 and triangle 2 both are in a congruent, we will say that. So for example, let us see the congruent symbol is, we represent the congruence with the symbol of this equal to an approximate. Okay, so where angle A is angle A is equal to angle P, okay, where this is satisfied, okay, I mean appropriately it is perfectly it is equal, where angle B is equal to angle C, where angle C is equal to angle R. Okay, so and similarly where side AB is equal to PQ, where BC is equal to QR, where AC is equal to PR. Okay, so that means this one, this side, I mean side AB and side PQ, and then BC and QR, and then AC and PR. Okay, so when these are satisfied, when the in terms of the side and strength, I mean size and side, okay, and angle A and inside of in terms of the angles are equal, then we say that both the triangles are the congruence of the triangle. So they both are in the congruent, we say that. Okay, so then let us also try to remember, okay, there are some of the congruence rules are there. Okay, so based on this also we can say that whether the given triangles are whether congruent triangles or not. Okay, so the first one is SAS criteria or SAS rule. Okay, congruency rule. So that means where side angle side criteria. So that means where the two sides and the one angle, where two sides SAS, where the two sides and one angle must be the equal. So now if we take the triangle ABC here, and if we take the triangle PQR, okay, so now let us look at here, the AB is equal to PQ. Okay, the AB is equal to, so this is the AB, this is equal to PQ. Okay, so and another one where AC is equal to PR. Okay, where this AC is equal to PR, and where angle A and angle P is equal to equal, where angle A is and equal to angle P, so angle P. Okay, so that means we say that these two triangles are in the congruency following the SAS congruency rule criteria. Okay, so there we can say that based on this we can say that both the triangles are the congruence triangles. Similarly, if you see angle side angle rule, so that means where two angles and one side must be equal. Angle side angle, so that means one angle and against the side which is corresponding angle to the side, and then another angle, they must be equal. Okay, so if you see here, okay, ABC, the triangle ABC and the triangle PQR here. Okay, so where the angle is angle A and angle P corresponding, so therefore it is a satisfied. Okay, and then angle B and angle Q both are the corresponding angles, we can say that it is a satisfied. Okay, where another side, okay, so between the the side BC is equal to QR. Okay, so why it is a base satisfied base is equal to QR? Okay, because this side is form the combination of the angle A and angle B. Okay, so therefore we say that this is angle side and angle. Okay, so when you say in this when triangles are in this condition, we say that the angle side angle, both the triangles are the congruence triangle based on the criteria or property of the angle side angle. Similarly, if you see another property where two angles and non-included side must match. Okay, so that means where the two angles and one non-included side. Okay, so here the side is included with the angles, but where here the sides are the not included with the angles. Okay, so if we match these two triangles, then we say that this both the both the triangles are in the form of both the triangles are the congruence triangles. Okay, so angle and side. So now if you see what are the two angles here, angle A and angle P, and angle B and angle Q, and the side is AC and PR. Okay, so AC is equal to PR. Okay, so then we say that these two triangles are the congruence of the triangle. Similarly, another property side. Okay, where all three sides are matching, all three sides must be equal. In this case, So let us look at the triangle ABC and triangle PQR. Okay, where AB is equal to PQ, where AB, the side of the AB is congruent to the side of the PQ. So that means whatever the size has the AB, length AB is having, the same size will also having the PQ. Similarly, the length of the BC is equal to the congruent to the QR. So that means equal to the QR. So that means the length of the BC is also equal to the QR. Then AC is equal to PR. Okay, so when we match like both the triangles, AC is corresponding to PR. Okay, so then this kind of situation we say that both the triangles are the congruent triangle based on the criteria of the side and side and side. Okay, then another one is right angle hypotenuse side. Okay, this is one of the another property where in a right angle triangle the hypotenuse and one side must match. One side and another hypotenuse should be matched in a given right angle triangle like ABC and PQR. Okay, where hypotenuse is the AC in the given triangle ABC, where hypotenuse is PR in the given triangle PQR. Okay, so where the both are the similar, so therefore we say that hypotenuse is the equal matching. Okay, similarly, what is the angle here? Angle B and angle Q, both angle B and angle Q are also matching. Another, what is the another side is matching here? AB and PQ. So AB is equal to PQ. This is one another side which are both are the matching at the angle B and angle Q. So then, so when the triangles are in this form, we say that the RHS, based on the RHS criteria, we say that both the right angle triangles are the congruent triangles. Okay. So another, congruency of the criteria where a angle and angle, which is not, we cannot value because angles may be equal, but if you see in the sides may be, sometimes it may be different. So therefore angle might be equal, like angle A is equal to angle P, angle B is equal to angle Q, or angle C, the angle C is equal to angle PQR. Okay, so the angles may be similar, but when you see the sides may be different. So therefore based on that we cannot say that okay, both the triangles are the valid. So if you want to say that these triangles are congruent, then we need to must again verify sides. Okay, so that is another condition is ACS. Okay, here also where the two sides and one angle. So based on this we cannot verify that these two triangles are the congruent triangle. Okay, only based on this properties. Further we should check the sides also. So these are the basic concepts which you have to remember. Most of the questions will be asking from the Pythagoras and Pythagoras triplet and congruence, the congruence of the criteria and definition of the congruence and the criteria of the congruence rules. Then let us see the one first question here. The question is like this: a ladder 25 meters long reaches a window of building which is 24 meters above the ground. What is the distance of the foot of the ladder from the base of the wall? Clearly read the question here. The question what it is asking exactly, there is a one ladder. Okay, the ladder is 25 meters long. That means the distance of the ladder is 25 meters, which is that ladder from the ground it reaches a window of building which is the 24 meters above the ground. So the building is constructed from the ground, our 24 meters high it is constructed. Okay, so that means so here the distance L is equal to ladder distance is L is equal to 25 meters and the height of the building is 24 meters. Okay, so that means they constructed building from the ground 24 meters. Now above the ground, so what is the distance of the foot of the ladder from the base of the wall? So that means if you see here, the foot of the ladder is here, the base foot of the ladder is here, and the base of the wall is here. Okay, so that this distance, what is the distance which we need to identify? So that is what the question is asking. Okay, where they are given building, where they are given ladder size they are given, and the building size size given from the ground, above the ground, and then they don't know from the the value of the point of the ladder and the point of the wall point. Okay, so that distance we need to identify. Now if you see here 24 meters and 25 meters. Okay, so the 24 meter is higher than the other side, so then we can say that it is so when you remember, like when you visualize this word problem into the mathematization when you do, so what will happen, it will exactly comes as a right angle triangle. Okay, so where 25 meters hypotenuse, and from this let us assume that this is the ground. Okay, this is the ground, and this is a building 24 meters. So when you see like this, okay, exactly it can be a Pythagoras, right angle, that means a right angle triangle. Okay, so we can represent in a right angle triangle where A, B, C, okay, where this is a building. So the from the ladder point to the window point, what is the distance? 25 meters, and the distance of building from the above the base point is 24 meters, and this distance we don't know. What is the base distance from the point to ladder point to the wall point? We don't know. That we need to identify here. Okay. So yeah, so now how we can do here this problem, how we can solve this one. We can just, when get the idea of, when you see the right angle triangle, when they have given the two sides, one more sides we need to identify. In such a cases, what we have to do, we have to apply the Pythagoras theorem here. Okay, Pythagoras formula we have to apply it. Okay, so now identify the hypotenuse we identified, and one side we identified. Okay, so if you remember the Pythagoras triplet, okay, so which I had told, like 5 Pythagoras triplet, but without any much calculation, applying the Pythagoras theorem, we can say that it is the value of length is the 7 meters, we can say. So which is the Pythagoras triplet which is satisfying the Pythagoras condition. But let us try to prove that, okay, through the Pythagoras theorem, whether the 7 meters is correct or not. Okay, since 25, 24 are the present, the missing base is explicitly 7. If so, this answer is based on explicitly from the remembering of the Pythagoras triplets. Okay, so therefore there is no calculations required. Okay, if you are not remembering those Pythagoras triplet, let us try to apply now. So here, what is the ladder here? Okay, so what is the length of the hypotenuse? That means ladder height is 25 square. Okay, so that is the hypotenuse. Now what is the height? That means perpendicular height they have given here from the base, it is a 24 square. Okay, so that is the value. So now what we need to identify? We need to identify the distance that we don't know. Let us assume that it is a x square. Now what is the formula of Pythagoras theorem formula, where hypotenuse is equal square equal to perpendicular square plus base square. Okay, so we have the hypotenuse we have, okay, we have the perpendicular we have, and base only we need to identify. So where base is equal to x, we are considering that. Now further, if you simplify this, 25 square become 625, and 25 square become a 625, and 24 square, 24 into 24 if you do, that will become a 576. 576. The x square will take it as a common. Okay, now as it is we will take it. Now if you simply, what we have to do, we need to identify the x square. So therefore we can write it like this: x square is equal to 625 minus 576. If it is go to, it will be plus 576. When it is take it to left hand side, it will become the sign will change, so that will become a minus 576. Now if you simplify this one, what will become? X square is equal to 49. So now we know that x square is equal to 49, where we need to find out the x value. So that is what we need to find. So x is equal to square root of 49. Okay, now remember the square root of 14. What is the value of 49? X is equal to 7 meters. So that is our value. So what is the, which option is correct? 7 meters. Option A is the 7 meters, option 2 is the 8 meters, option 3 is the 9 meters, option 4 is the 10 meters. So option A 1 is the correct one, 7 meters. Okay, so if you remember the template, we don't need to do this much all the calculations. We just, by seeing the numbers 24, 25, we can say that this answer, we can guess the answer immediately. Okay. So how we can remember, like whether we need to apply the Pythagoras theorem or not whenever we see the word problems. Okay, in such a cases, what we will do here, so we just recall the words like wall. Whenever they ask, whenever they give you the wall or vertical pole or ground distance and ladder shadow, so that must be this kind of word problems. Always questions will be always related to right angle triangle. So whenever you remember the right angle triangle, then you must apply the Pythagoras theorem. Okay, so remember that is the one key point. Okay, so now so that means where Pythagoras theorem can be connected to the real life situations. Okay, so and then, so first identify the sides. What are the sides they are given? Okay, imagine yourself like what they're exactly they're asking, like ladder, what is the distance of the ladder, then what is the building of the height, okay, what is the base here. Okay, then once you just imagine like that, try to convert into mathematization. Okay, then identify that the given problem is, it is in the form of right angle triangle. Try to put it in a right angle triangle. Okay, so then apply the Pythagoras theorem, we will get the answer. Okay, so this is one way of doing. Now So there is another problem like this. Okay, a 13 meters long long ladder is leaning against the vertical wall. Okay, so there is a vertical wall which is again it is leaning to the vertical wall, that is the ladder which is having the height of the 13 meters. The foot of the ladder is 5 meters. So that means one side the base they have given. Okay, the foot of the ladder is 5 meters they have given. Okay, and then the foot of the ladder is 5 meters away from the wall on the ground. Okay, so that means from the ground point, okay, the foot of the ladder is 5 meters away. So that means the base of the distance they have, length they have given. Now how high up the wall does the ladder reach? So that means the height, perpendicular height from the base to the building distance. So that we don't know, so that we need to identify. Okay, so how we can do here? So identify the keywords. So that means, as I said, like wall, vertical, ground distance. So that means the question is related to right angle triangle Pythagoras sum. Okay, so then draw a right angle triangle. So like this, you draw a right angle triangle or draw a right angle triangle like this. Okay, based on the given. So that means ladders. So if you observe here, what are the values they have given here? 13 meters ladder, and what is another value they have given? Base they have given is a 5 meters. Okay, so where 13 meters is higher than the 5 meters. So therefore we can say that 13 meters is the hypotenuse. Okay, which is the longer side. If you see the Pythagoras theorem, if you remember, what will happen? The hypotenuse, the highest side will be the hypotenuse, and other smaller sides are the another two sides. Okay, so one side they are given, and another side is hypotenuse they are given. We need to identify the another side, that is what we need to identify. So the perpendicular height only we need to identify. Okay, so perpendicular height h we don't know that. Okay, and then base they are given, and the hypotenuse they have given. So just apply the these values in the Pythagoras theorem. So that means, like the Pythagoras theorem, if you remember, x square is equal to p square plus b square. Okay, so the p we need to identify, h they have given, p they have given. So if we apply that, we'll get h is equal to 5 square and 13 square. Okay, so 13 square is 169, 5 square is the 25. Okay, so when you subtract 25 from the 169, we will get the 144. Okay, so now h square is equal to, so that means this is a hypotenuse, sorry, this is the perpendicular. H square is equal to square root of 144. Okay, so I mean h is equal to 144. Now what is the h value? So we will become 12 into 12, 144. So the value of h is 12. So, okay, so that is this is what Pythagoras theorem. Whenever they give the word problems and ask them to identify the Pythagoras theorem, we can solve like this. Or if you remember the direct triplets, okay, of triplets of 5 triplets, which is majorly focusing on giving questions based on those triplets only, directly without applying even Pythagoras theorem, we can solve it. Okay, now another question is like this: if triangle ABC congruent to triangle FED, the triangle FED, under the correspondence of like ABC to corresponding to FED, which of the following statement is false? Okay, so they are given the, remember the congruence of the concept, triangle of the congruence of the triangle. Okay, so what, there are two triangles they are given here. The triangle one is the triangle ABC, which is congruent to, I mean corresponding to another triangle. The triangle is FED. Okay, now there are some of the statements they are given in the options. We need to check that whether that option is correct or not, and I mean which is the false statement we need to check. Okay, so now if you remember the congruence of the concept here, so let us see first. Okay, what are the options they are given, where AB is equal to FE, angle B is equal to angle E, option 3 is AC is equal to FT, and the option 4 is angle C is equal to angle E. Okay, so now align, now given by seeing the options itself, we can say that if you remember the concept of the congruence triangle, by seeing the options itself, we can say that within the fraction of seconds, the option 4 is the correct one. So where it is the false statement. Okay, so now but let us try to apply the concept and see that. Okay, in a triangle ABC, okay, ABC, the first let us map with the A. Okay, so A is congruent to the F. Okay, so that means angle A is equal to angle F. Okay, so the second B and E, the point you see that. Okay, where B and E are the corresponding of in the triangle ABC BN and triangle FED E are the congruent. Okay, so B maps to E, where third is C maps to D. Okay, then this is the fine. Now in a triangle ABC, triangle FED, under the correspondings ABC and FED, by applying the CP-CT rule, the corresponding parts of the congruent triangles are the equal. So that means the corresponding triangle we are trying to check here. What are the corresponding side of the AB here? Corresponding side of the AB is corresponding side of the AB in a triangle ABC. The corresponding triangle of the FED is the FE. Okay, so that is the correct one. Okay, so that means this one and this one. Now the corresponding side of the BC is corresponding side of the BC to what is the corresponding side of the BC in a triangle FED? That is the ED. So that is also satisfied. So that means this one and this one both are the satisfied, both are the equal. Similarly, the triangle ABC, the side of the AC is corresponding to FT. Okay, the side of the corresponding, the side of the AC in a triangle AC, which is corresponding to triangle FED. Okay, so this condition is also satisfied. Now let us look at the corresponding angles here. Angle A is equal to angle F. Okay, angle A is equal to angle F. This is the satisfied. Now angle B is equal to angle E. So that is also satisfied. Where angle C is equal to angle D. Okay, so that is also angle C is equal to angle D. So satisfied. Okay, but in the given options, are they given? What is the given here? Angle C is equal to angle E. They have given. So this is the false statement. Okay, so this is the correct answer. They are asking which of the following statement is the false. So this is the false statement. Therefore, this is the correct answer. So for this kind of question, remember the congruence of the triangle concept and try to see the map with that. Okay, whether corresponding in a given two triangles or corresponding sides, corresponding angles, or equal or not. Okay, so if we have the based on that concept directly, we can, by seeing the options itself, we can answer this question. Okay, now the next question is, the question is like this: the sides of the triangle are 6 centimeters, 8 centimeters, and 10 centimeters. Find the area of the triangle. Find the area of the triangle we need to identify. The sides of the triangle they have given, like there are three measurements they have given of the triangle. The values are like this: 6 centimeters, 8 centimeters, and 10 centimeters. So we need to find the area of the triangle we need to identify. Okay, so now the options are like this. Option 1 is the 48 centimeter square. Option 2 is the 24 centimeter square. Option 3 is the 14 centimeter square. Option 4 is the 40 centimeter square. These are the four options they have given. Now let us try to identify. Okay, so when you see the 6, 8, 10, okay, so again same. So if you have the Pythagoras, if you remember the Pythagoras triplet here, 6, 8, 10 are the multiples of the 3, 4, 5. Okay, where 3 2s are 6 and 4 2s are 8 and 5 2s are 10. So these are the exactly double of the Pythagorean triplet of the 3, 4, 5. Okay. And then since 3, 4, 5 are the satisfying Pythagoras condition, so we can say Pythagoras satisfying the right angle triangle. So then we say that longest side is the, so in the given 6, 8, 10, the longest side is the 10, that is the hypotenuse. Okay, so now we got the source, that means we identify that the given triangle measurements are in the form of right angle triangles. So therefore we are trying to represent mathematization in the form of right angle triangle, where height is the 10 centimeters square and another side is the 6 centimeters, the perpendicular, then another side is the 8 centimeters. Okay, so now we got it the values. Okay, so now what we have to do, what they are asking, find the area of the triangle we have to find. So what is the formula of the area of the triangle? So area of the triangle, so when you see the area of the triangle, okay, so to find out the area of the triangle, what is the area of the triangle? Half into this base into height. Okay, h, so that means base into height. Okay, so now apply. So we have the base, we have the height. Okay, we have the hypotenuse here. Okay, we know the values. Okay, now just try to apply these values into the formula, we'll get the answer. Where half is equal to base is equal to 6, height is equal to 8, then half into how much it will become, that is 8 6 are 48. Okay, if you 48, if you just cancel with the 2 1s are 2 24s are 48, so the answer will become 24 centimeters. What is the option here? Option 2 is the correct answer, 24 centimeters square. So without if you remember the Pythagoras triplets, directly we can solve like this. Okay, if you do not remember the Pythagoras triplet, what we can do, we can given values apply in the Pythagoras theorem. Okay, so that means verify that whether the triangles are confirmed or not. Okay, so then once it is confirmed, then try to apply the given values into the area of triangle formula. Half is equal to base into height. Okay, you will get the solution. Now check so now let us see that, okay, so whether the triplet triangulation for the area or not, correct or not. Okay, if the sides of a triangle from a Pythagorean triplet like ABC, like previous problem which we discussed, such that it will become a square plus b square is equal to c square. Okay, so now the triangle, so once it is satisfied this condition, we'll say that it is a right angle triangle. Then the area is become off into smaller side into other smaller side, where we apply in the previous problem like this. Okay, now for the triplets, check if the given sides are satisfied. Okay, then identify the right triangle from the given values, then take two smaller sides than the other side. Okay, then apply the formula of area is equal to half into base into height. Okay, so then we'll get the answer. So this is the way which regularly we have solved the previous problem by applying this concept. Now for example, one more, find the area of the triangle whose sides are the 5 centimeters, 12 centimeters and 13 centimeters. Now you check the given 5 centimeters and 12 centimeters and 13 centimeters. Again, these are the triplets of the Pythagoras theorem. So then we check that this, okay, by we check that by doing the square, 5 square plus 12 square plus 13 square, we got it this 169. Okay, so we are confirming that the given values values are the Pythagoras triplet values. Okay, then identify the right triangle here. Okay, so the triangle is the right angle triangle. Okay, so if once the values are in the Pythagoras triplet, we will confirm that the given values are in the Pythagorean triplets. Okay, so now what we have to take the small to take the two smaller sides. So in the given 5 centimeters, 12 centimeters, 13 centimeters, what are the smaller sides here? 5 centimeters and 12 centimeters are the smaller sides. Now what we need to identify? We need to identify the area of the triangle. So therefore, what is the formula of the area here? Okay, so area is equal to half into base into height. Okay, let us assume that base is 12 centimeters and height is the 5 centimeters. So when you apply this, we'll get the solution, that is the 1 by 2 into 12 into 5, 30 centimeters square. Okay, so this is so the given area of the triangle is 30 centimeters square. So whenever ask the problems from the Pythagoras concept, we can do like this. So remember, only 1 2 3 4 5. Okay, so these 5 most of the times in the common triplets are these are the 5 common triplets where questions are focusing based on these common triplets. Now the next one is in a triangle PQR and triangle XYZ, PQ is equal to XY, where QR is equal to YZ and angle Q is equal to angle Y. Which congruency criterion ensure these triangles are the identical? Okay, so that is what we need to identify. Okay, so now if you see that, okay, in a triangle PQR and triangle XYZ, okay, where PQ is equal to XY, that means the one side is satisfied here. Okay, so that means, okay, where one side is the satisfied here, and QR is equal to YZ, then another side is also satisfied. Okay, so in between angle Q is equal to angle Y, so that means angle Q is equal to angle Y. So if you have the remember the criteria of congruence triangles rules and criteria, directly by saying the option we can say that the given congruence criteria ensure that the triangles are identical based on the SAS congruence of the triangle. Okay, so if you see like this, that is what are the given here, PQ is equal to XY, that is the first side is confirm that it is satisfied equal, and the second one is QR is equal to YZ, that is also condition satisfied, where angle Q and angle Q, so the angle Q and angle Y were included between the two sides. These are the side 1, side 2, for this side 1 and side 2, okay, which is corresponding sides. So that angle also similarly it is equal. So therefore from this we can say that the given triangles are the congruence based on the concept of the SAS congruence triangle. Okay, so yeah, so why not other? So for SAS is required need 3 sides, only three sides, but where they are in the given question has given only 2. So another second option, if you see the ASA property where only the 2 angles and only one side, but in the question they ask the 2 sides and only one angle. So therefore this is also wrong, this is also wrong. If you see the last fourth option, which is a completely right angle right angle triangle, okay, need applies to right angle triangle, so they didn't give any right angle triangle, so therefore that is also correct, wrong answer. Only option 3 is the correct one. Now how do you verify that if criteria based on the this SAS criteria or okay, whether it is correct or not? Okay, so now for valid SAS, given PQ is equal to ST, okay, then QR is equal to T in the given triangle QR, the T R is also correct one, where angle Q is equal to angle T. So therefore we say that angle Q and angle T are the included angles between the given sides. Okay, so therefore this is SAS criterion is valid. But whereas this is also property of SAS, but it is invalid. So how means, because PQ corresponding is the ST, okay, where PR is the side of the PR is corresponding to the SU, and where angle P is equal to angle S. Okay, but the angle is not the because but if you see the angle P and the angles are not between the two given sides, so that this is another side of the angle. So therefore we say that SS is not a valid. Okay, so another thing is that given triangle QPR and the triangle TSU, okay, where QR equal to TU, where PR equal to SU, and angle R is equal to angle U. Okay, but angle R, angle E, if you see that they are not between the two given sides. Okay, okay, so therefore we say that it is not a valid. Okay, so this is the even the triangles are in the congruence triangle. Okay, so if the angles are not if the triangles and angles are not between the given sides, then we say that it is not the valid SAS triangles. So angle must be between the sides, not anywhere else. That is the heart of this criteria of the SAS. Now the question is, another question is, a man goes 15 meters due north and then 8 meters due east. How far is he from his initial starting point? Okay, this is a very much important thing, a question. There are a number of questions will be asking like this. Okay, now remember the directions here. This is the east, west, north, south. Okay, if you remember. Then a man goes 15 meters due north. So let us try to put it. Okay, so where this is the starting point. Okay, and he is walking towards north from the how much distance he walked? 15 meters. Okay, then he from the north. Okay, then again 8 meters he walked towards the east. So if you see from here, this starting point, okay, he went to the from starting point to north, he went from the north, again he took the right side. So what is the which direction of right side? So that means it represents the east side. Okay, so east side, that means becomes a right. So that means the right he walked the 8 meters he walked. Okay, now if you see from the starting point to the ending point, okay, so where the starting from to end ending point, the distance that is covered, the it is exactly in the 90 degrees covered. Okay, the shortest distance represent the hypotenuse. So that means if by saying this figure, we can say that the given values are, it is in the form of again right angle triangle. Okay, so the visual representation we can say like this. Okay, the same thing, this is the starting point where you walked towards the north 15 meters. From that again he took the east 18 meters. Okay, now this is a distance which you don't know, so that we need to identify. So for this case, what we can do, we can identify by applying the Pythagoras theorem here. Okay, so turning from north to east, create exactly. So from the starting point to reaching to north, from north to east, when you walk when you travel this much, this distance creates exactly 90 degrees at the perpendicular intersection. So this point. Okay, now the given legs of the journey, how much? 15 and 18. Okay, so this is the base 15 and the hypotenuse the perpendicular is the 8 meters given. Okay, the hypotenuse we don't know, that we need to identify. So if you remember the again triplets of 8, 15, 17, so we know already 15 and 8 is there. Option, if you see that whether 17 is there, then directly we can say that the 17 meters, the distance of starting to the reaching end point, the distance will become 17 meters. If you do not remember the triplets, directly we can, so what we can do, we can apply into the Pythagoras theorem, where the distance is equal to north square plus east square. So that means directly we can h square is equal to, let us assume that this is a perpendicular P, this is assume that it is a B. Okay, h square is equal to P square plus B square. Okay, so this we need to identify. Let us assume that this is x square, and then P square is the what is the p? 8 square plus base is the 15 square. So if you simplify this one, 8 square becomes 64, 15 square 225. Okay, that means x square is equal to square root of 2025 plus 64. Okay, so where this will get x. Okay, so then x is equal to square root of 289. Okay, where x is equal to 17 into 17. Okay, so the value of 17. So if you apply this also you can, but if you remember the Pythagoras triplet, by seeing the numbers itself you can identify the answer within the fraction of seconds. Now remember the cardinal directions. Okay, whenever the questions asked like from the directions, okay, where the north, south, east, west intersect the right angle on a flat plane, where any movement mapping linear displacement between the perpendicular direction sets up a right angle triangle. Okay, so whenever directions, when they move from north to south, east, west, okay, intersect at a point from one direction to another direction when they move. Okay, so that place it the direction set up a right angle triangle. So suppose like east, let us assume that east is a 0 degrees. Okay, when they move from the east to north, okay, so that means 90 degrees they are moving. So then when they move from so that means east, north is perpendicular to east, where and east is the perpendicular to south, and south is the perpendicular to west. Okay, this is the south, it is perpendicular to west. Okay, this point, and then west is the perpendicular to north, so this is a perpendicular to north. Okay, so in these conditions what will become, all the intersection points are makes the exactly 90 degrees. In the previous problem what happened here, he moved from the one point to north and then he moved to the south. Okay, so that the intersection point makes exactly 90 degrees. Okay, so for example 15 meters north and then 8 meters east. Okay, so from starting point he moved from the north 15 meters and then from there to 8 meters he moved. Okay, so when he moved, then the intersection point makes exactly 90 degrees. This is the 90 degrees. Okay, then this is what. Okay, now let us see another question. Okay, which of the following cannot be the structural dimension of the right angle triangle? Okay, so which of the following cannot be the structural dimension of the right angle triangle? So the option A, the option 1 they are given 5 centimeters, 12 centimeters and 13 centimeters. Option 2 is 8 centimeters, 15 centimeters, 17 centimeters. Option 3 is the 7 centimeters, 24 centimeters, 25 centimeters. Option 4 is the 6 centimeters, 9 centimeters and 11 centimeters. Again, okay, here the question is which of the following cannot be the structural dimension of the right angle triangle? So if you see the option 1, 2, 3, all is all are the Pythagoras triplets. Okay, 5, 12, 13 are the Pythagorean triplets. 8, 15, 17 again these are the Pythagorean triplets. Again 7, 24, 25 are the Pythagoras triplets. Only the option 4 is the 6, 9, 11 are the not the Pythagoras triplets. Therefore, if you remember those things directly, we can say that option 4 is now cannot be the structural dimension of the right angle triangle. So let us but try to verify that. Okay, so now if you verify in Pythagoras theorem, okay, so if you verify the Pythagoras theorem, okay, what will happen? So option 4 will be the not equal to the 1. See, if you verify the, let us verify the option 1. Okay, so the sides 5, 12, 13, okay, they are given. Okay, so 13 square is nothing but 169. So 5 square, 12 square will become a 25 plus 144, that is also will become 169. So therefore the option 1 is the satisfied. And the second option is 8, 15, 17. 17 square will become again 289. Okay, 8 square will become a 64 and 15 square become a 225. Okay, when you add the 64 plus 25, again it will become a 289. Okay, so where the 17 square is equal to 8 square plus 15 square, so that is also Pythagoras triplet. Okay, now option 3, if you see that 7 square is nothing but 49, 24 square is nothing but 576. If we add the 14 and 76, it will become a 625. Okay, so where if you 25 square if you do, again it will become a 625, where the condition is satisfying. 625 is equal to 625 Pythagoras triplet. But whereas if you see the fourth option here, 6 square is equal to 36 and 9 square is equal to 81. Okay, if you add the 36 plus 81, it will become a 117. So but if you if you square the 11 square, the 11 square is nothing but 121. So where 6 square plus 9 square, that means 36 plus 81 become 117 and 11 square is become 121. Therefore it is not a equal, so that is a unequal. So therefore we say the option 4 is the cannot be the structural dimension. So for this we don't need to cancel, we don't need to calculate this much, okay, when you remember the Pythagoras triplet. Okay, if you remember that within a fraction of seconds by seeing the options itself, we can answer for this question. Okay, so let us see what is the converse Pythagoras laws. Okay, for any triangle sides a greater than or equal to b, greater than equal to c, where c is the longest side. In such a cases, if a square plus b square is equal to c square, then it will becomes a right angle triangle. If a square plus b square less than the less than the c square, okay, then that will become obtuse angle. If a square plus b square greater than the c square, that means the value whatever we got it of a square plus b square, if it is a greater than the c square, then we say that is the acute angle. Okay, so first similarly let us see like sides 3, 4, 5. Okay, where if you apply this triplets 3, 4, 5, we will get the, so we can see that a square plus b square is equal to c square. So in this condition we say that this is a right triangle. Okay, but whereas if a square plus b square is less than c square, then we say that it is obtuse angle. Okay, if it is greater than, we say that acute triangle. So now the next question is, if triangle ABC congruent to the triangle PQR, where AB is equal to 5 centimeters, BC is equal to 6 centimeters, and angle B is 40 degrees, then what is the value of PQ and angle Q? They're asking what is the value of PQ in a triangle PQR, and what is the value of angle Q they're asking. So this is very easy question. Okay, so if you remember positional in the congruence of the triangle of the concept and positional correspondence, we can, by seeing the options itself, we can we can select the answer here. Okay, so let us try to identify the answer. In a triangle ABC, the A is corresponding to P, okay, where B is corresponding to Q, where C is corresponding to R. Okay, so that means all are corresponding sides and sides. Okay, then AB is directly mapped to the PQ, where AB is equal to 5 centimeters. So therefore the PQ also must be 5 centimeter. Why it should be 5 centimeter? Because based on the congruence of the triangle here, or concept here. Okay, so therefore by this option we can eliminate that option 2, and option 2 can be eliminated, option 4 also can be eliminated. Why? Because PQ here they have given 6 centimeters and 6 centimeters they are given, but what is the should be the value here? PQ should be the only 5 centimeters. So now option 1 and option 3 is the left, so whether it should be the option 1 or option 3. Okay, now let us look at another thing. The next position B, the B should be corresponding to the Q. Okay, so now what is the angle of the B? They have given 40 degrees. So since B corresponding to the Q, the angle Q also must be 40 degrees. Okay, so now if you see the angle Q is equal to 40 degrees. So therefore option 1 is the correct answer. Option 2 is we can be eliminated. Okay, so even if you cannot remember, we can see that, okay, manually we can verify, we can check that, okay, where corresponding angles are angle B is equal to angle Q, corresponding sides where BC is equal to Q are 6 centimeters, corresponding sides, okay, AB is equal to Q is equal to 5 centimeters. By remembering the concept also we can verify. Then the another concept is CPCT concept, where corresponding parts are of the corresponding parts of the congruent triangles are the equal. Okay, so congruence of first proven, okay, where in the given triangle ABC we are saying it is congruent to triangle DEF. Okay, by congruent rule like this, with these rules we say that, okay, where A is corresponding to D, and where B is corresponding to E, and where C is corresponding to F. Okay, so if you apply that from the triangle ABC, triangle DEF, okay, by CPCT, so that means corresponding parts, corresponding triangles, we can say that where AB is equal to DE, okay, where AB is equal to DE, and where BC is equal to EF, and where AC is equal to DF, all corresponding sides are the equal. Okay, let us see the corresponding angles. Angle A equal to angle D, angle B is equal to angle E, angle C is equal to angle F. So even the corresponding angles also equal. Suppose if angle B and angle F is here, okay, can we say that angle B is equal to angle E? No, we cannot say that. In this case this will become a wrong. So it should be angle E only. Okay, so for example, based on this concept, some of the questions they are asking. For example, if you see, if a triangle ABC congruence to triangle DEF, where AC is equal to 7 centimeters and angle B is equal to 50 degrees. Find the DF and angle EA. They are asking to find out. So based on the CPCT concept, congruence parts of the congruent triangle, we can say that where DF is equal to AC, that is the 7 centimeters, and angle E is equal to angle B is the 50 degrees. If by observing this also, we can say that where angle B is between the sides of the AC, or here also angle E is between the sides of the DF. By seeing the question itself, we can say that both are the given triangles are the congruence of the triangle by CPCT rule. Similarly, the second, if triangle PQ are congruent to the triangle XYZ, where PQ is equal to 5 centimeters, QR is equal to 6 centimeters, angle P is equal to 60, angle QR is equal to 70. Find the XY, YZ, angle X and angle Z. So by applying these congruence parts, congruent triangle, so where XY is equal to PQ, that is with the PQ 5 centimeters, where YZ, so that means if you draw the figure like this, PU, QR and another figure, where X, Y, Z, where PQ and XY, these are the 5 centimeter according to the question. So that means this also must be 5 centimeters. So that is the condition is satisfied. And another condition is YZ, this is the 6 centimeter. Then QR also it must be, based on the CPCT, it must be 6 centimeters. This also condition is satisfied. So now value of the, what is the P value? Angle P, they have given 60 degrees. Similarly, this also based on the CPCT, it will become a 60 degrees. Therefore, this condition also satisfied. Where now angle R, they have given 70 degrees and angle Z, they have given the 70 degrees. So this condition also satisfied. Therefore, we can say both triangles are the congruence triangles. So you must always look at how they are, triangles they are in the they are giving. So triangle PQR means PQR, triangle XYZ means XYZ. So that is the important way of representing. Now the next question is, if a right angle triangle, the hypotenuse is 13 centimeters and the base is 12 centimeters, find its perpendicular height. Now in the right angle triangle they are given, so try to draw the right angle triangle ABC. And the hypotenuse they are given 13 centimeters and the base they have given 12 centimeters. Now they are asking you to find out the perpendicular height. So we know that. Again, see, if you see again 12, 13, if you see again, immediately should come into your mind. These 12, 13 is the triplets of the Pythagoras theorem. So which is the missing 5. So 5, 12, 13 are the triplets of the Pythagoras. So if you remember that thing, directly we can say that option 1 is the correct answer. So here they are given the hypotenuse, they are given the leg. We need to identify the missing perpendicular. So or if you do not remember again, we can just apply the Pythagoras theorem here. And then we can identify the apply the values in the Pythagoras theorem and simplify, and we'll get the answer 5 centimeters. So how it is, like, see, now we need to identify what we need to identify. We need to identify the height. We need to identify. So based on the Pythagoras formula, like h square is equal to p square plus p square. So what we need to height, that means perpendicular, we need to identify. So convert this formula into write in terms of where p square is equal to hypotenuse. So that means this will go to the this base will come to this side. So that means the formula will become h square minus b square is equal to p square. So where this is the height. Height square is equal to base. Base square and hypotenuse square. So now apply these values. This is what we need to identify. We know the hypotenuse, we know the base, we know. What is the height here? 13 square. What is the base here? 12 square. So when you do the square, this will become 169, this will become 144. That is the perpendicular p square. Now if we need to identify the value of p. So it become this, if you simplify, we'll get the 25. So if you convert p, write the p is equal to square root of 25, the value of the root 25 is the 5. That is the option 1. So this also you can beat, or if you remember these triplets easily by seeing the option, we can identify the answer. So we are almost end of the session. In this session, let us try to revise what we have discussed. So we have discussed the Pythagoras equation, which is always look for the right angle. So whenever they ask the give the right angle triangle, so we have to apply the Pythagoras theorem, where h square is equal to p square plus b square. That is the formula of that one. Okay. So remember, where h is the hypotenuse, where is the p is the perpendicular, and b is the base. And also try to remember the triplets of the shortcuts. Okay. If you know the basic triplets of Pythagoras theorem, almost we can save the time in when you are solving the questions based on the Pythagoras theorem. So such as like one triplet 3 4 5 5 12 13 8 15 17, most of the questions are asking based on these triplets only. Then we also discussed the congruency criteria checklist. Okay, what is the meaning of the congruence, how the given triangles whether congruence or not, how we can verify, and what are the criteria rules of the congruence triangles, like the SSA criteria, SES criteria, ASA criteria, where angle side criteria, and RHS right angle side criteria. Okay, so whether these criteria are valid or not. Okay, there are some of the questions asking based on these criteria also. If you remember this criteria, it's very easy to remember. The questions can be easily solved. Then another concept we have discussed, CPCT rule. Okay, so that is where corresponding parts of the congruence of the corresponding parts of the triangles. Okay, so if you remember that given triangles, we can identify based on this rule whether given triangles are congruence triangles or not. We can say that. Okay, where we need to map with whether in a triangle ABC, triangle PQR, okay, whether A is corresponding to P, or whether B is corresponding to Q, and whether C is corresponding to R, and whether given angle A is corresponding to P, and angle B is corresponding to Q, and angle C is corresponding to R. Okay, so if you remember this CPCT rule, based on the given triangles, we can identify whether the given triangles are the congruence or whether it is equal or not. Okay, so identify, apply, and these formulas remember. So whenever the questions asked from the CTET paper 1, paper 2, Pythagoras theorem and congruence, easily we can score from these concepts. And with this we are ending the session, and thank you.